Okay, today's section, this is 7.4, and these are fractional equations. So today's equations are going to look really similar to yesterday's equations. The difference between yesterday's equations and today's equations is yesterday, all of the denominators were just numbers, right? 2 and 4 and 7, you had to find the least common denominator, and away we went. Today, there are going to be numbers in the denominator, but there might also be variables. Okay, so there's kind of two ways that changes things. One way is it's going to make finding the least common denominator a little different. So that's the first thing we're going to do. We're going to look at some equations, and we're not going to solve them, but we're just going to decide what would the least common denominator be if I wanted to solve this one. Okay, so if we first look at 9 over 2a minus 5 over a equals negative 1/4. Okay, so yesterday it would have just said 2 and then maybe a 3 and then a 4. There wouldn't have been a's, but notice how there's a's down there. So really the only difference is one thing. We're going to do the numbers the same way. So still look just at your numbers. So I have a 2 and a 4. What would be the least common denominator between 2 and 4?
8.
Smaller than that? 4, right? You could use 8 and 8 would work. But if we're looking for the smallest, we could use 4. Okay, but keep in mind that the reason why we're finding the least common denominator is so it will eliminate these fractions. Okay, so if I multiply by 4, well, that fraction will be gone, right? If I multiply by 4 here, the 2 will go away, but that a will not. And if I multiply by 4 in the second term, that a isn't going to go away. So remember, we want to get rid of our fractions. So think of what we've kind of done in the past. How would I get rid of these a's in this denominator?
Multiply by 2a.
Right, multiply by an a. Okay, so our least common denominator is going to be 4a, because that was the number part of our least common denominator. So now, remember, we want to get rid of our fractions. If I multiply by 4a, well, that denominator is going to go away. That denominator will go away, and that denominator will go away, okay? Just keep in mind that's why we're finding the least common denominator, so we can eliminate them. Does that make sense? Okay, let's look at just one more of those. Some of them today will look like n over n minus 2 equals 6 over 5. Okay, so this one looks a little different. So in the first one, we looked at our numbers, found the least common denominator, right? And then just kind of included the variable. Let's think along the same lines here. So look just at this fraction. Let's start with this fraction. What would you have to multiply to get rid of the 6/5 as a fraction? A 5, right? You would multiply by 5. So that 5 is going to have to be a part of my least common denominator if I want to get rid of all my fractions. Do we agree? Okay. Well, let's look over here. How could you get rid of this n over 2 in a denominator? Not by 5, right? Because if I multiply by 5, it's not going to get rid of it. What would I multiply by? What did you say? Itself. If I multiply the left-hand side of this fraction by n over 2, won't that eliminate my denominator? Yeah, if you multiply by whatever's in the denominator, it's going to cancel itself out. So the least common denominator is actually going to be 5 times the quantity n minus 2. Okay? So one thing that's different, we have to look a little bit differently at our least common denominator, but really not a whole lot different. Okay? Questions on these first couple of examples? Okay, we really don't have any new notes. We're just going to jump into some examples, and I'll show you the other difference in this first example. So number 1, we want to solve 1 over 6 plus 2 over x equals 2/3. Yesterday, the first thing we did is we found the least common denominator, and then we multiplied both sides by the least common denominator, and we could solve. We're going to do the same steps here, but we have one extra thing we have to do. First, let's look at our least common denominator. Keep in mind, we're trying to eliminate all of the fractions. So I want to get rid of the 6, the x, and the 3. So what number, what term could I multiply by to eliminate all 3 of those? 6x. Very good. If I multiply by 6x, all of my denominators will cancel out. Okay? Now today, before we go through and multiply both sides by the least common denominator, there's one other thing we have to do. Because the difference between today and yesterday is today we have variables in the denominator, right? That's what we've kind of been seeing with this least common denominator stuff, is we have to look at those a little differently. This also matters because if we ever have a variable in the denominator of a fraction, it complicates things just a little bit. Anybody know why? What do you think?
It can't be 0.
Good, awesome. It can't be 0. Because what if x is 0? What happens to the whole equation? It doesn't exist, right? It's undefined. We cannot have 0 in the denominator of a fraction. So we have to state kind of restrictions, okay? Because if I solve this equation and find out that x is supposed to be 0, well, look, if I plug it back in, x can't be 0 because that means that the whole thing doesn't exist. So the first thing we're going to do is we're going to find the least common denominator. The second thing we're going to do is we're going to decide if there's anything in this equation that my variable could not be looking at the denominator. So in this case, I'm just going to say x can't be 0. Okay? Now sometimes you'll use this piece of information, and a lot of times you won't. A lot of times you'll write it down and you won't need to use it, but at least we have it. Okay? So the rest of this is the exact same as yesterday. We're going to multiply both sides by the least common denominator. So multiply everything by 6x. So we're going to take 6x times 1/6, 6x times 2 over x, and 6x times 2/3. And then this step is the same as well. We're going to go through. All of my denominators should cancel out. So I can divide out a 6, and I'm just left with an x. This time I can divide out an x, and I'm left with 6 times 2, which gives me 12. And then on the right-hand side, I can divide out a 3, and I'm left with 2x times 2, which gives me 4x. Okay, and then I just have an equation to solve, so get my x's on the same side of the equal sign. So subtract x from both sides. So 12 equals 3x. Divide both sides by 3, and we should end up with x equals 4, if it will catch up. Okay, so hopefully you guys have that on your paper. Okay, so x equals 4. Whenever you have your answer today, just double check. Go back to where we wrote our restriction. I said x couldn't be 0. And I found that x equals 4, so really this time the restriction didn't matter, okay? If I solved my equation and I found out that x equals 0, so let's say instead somewhere along the way this ended up saying x equals 0, what do you think my answer would be? No solution, right? Okay, does that make sense? Okay. All right, number 2. 6 over 5y minus 2 over 2y equals 1/4. Rid of the 5y, the 2y, and the 4, Leah. Very good. 20y. Okay, and then before we get started, we need to make sure if there's any restrictions. So is there any value of y that would make any one of my denominators 0? Is there something that y could be that would make this 0? 0, right? What if y is 0? Once again, if y is 0, that denominator is going to be 0, and that denominator is going to be 0. So once again, my restriction, y cannot be 0, okay? All right, so let's go through. Multiply both sides by my least common denominator, which is 20y. So I have 20y times 6 over 5y minus 20y times 2 over 2y equals 20y times 1/4. Okay, I want you guys to go through this one, finish this one, cancel out your denominators, and solve your equation, see what you get. Okay, hopefully you got y equals 4/5. Whenever your denominators all cancel out, you get 24 minus 20 equals 5y, which means 4 equals 5y. Divide both sides by 5, and you get y equals 4/5. Okay, any questions on this example? No? Doing good? Yep. Like I said, pretty much same thing as yesterday, just a couple extra things to add in. Okay, number 3. z times z over z minus 1 equals 9 over 8. Z over z minus 1 equals 9 over 8. Okay, first thing, my least common denominator. We haven't done one of these for our examples, but we did talk about this at the very beginning. Remember, we're looking for something that I can multiply by that would get rid of the 8 and the z minus 1. What could I do, Rebecca? Very good. 8 times the quantity, z minus 1. That's going to cancel out this z minus 1. That will cancel out this 8. Okay, now this time, the restriction may not come right out at you, but let's think about this. Look at this denominator here. This can't be 0. So what value of z would make that denominator 0? Eric? Right, if z was 1, then that whole thing would be 0. So this time my restriction, I know that z cannot be 1. Okay, does that make sense? Yep. Okay, so I want you guys to try this one. So go ahead and multiply. Well, no, we'll do this one together because it's a little different. Okay, so we'll do 8 times the quantity z minus 1 times z over z minus 1 equals 8 times the quantity z minus 1 times 9 over 8. Okay, these look a little different, but remember I'm multiplying by this z minus 1 so it cancels it out. So this z minus 1 and that z minus 1, those cancel, okay? And I'm left with 8 times z. And then over here, this 8 will cancel out with that 8. And I'm left with 9 times the quantity z minus 1, okay? And then we'd have to distribute the 9, get 9z minus 9. Get my z's on the same side of the equal sign. So subtract 9z from both sides. So I have minus z equals minus 9, but I don't want to know what minus z is. I want to know what a positive z is. So if negative z is negative 9, what is positive z? Just 9. Okay. And then just double check. Does this fit in? Does it fit in with my restriction? Does it cause a problem, I guess was my question. No, because I said z can't be 1, and I got z equals 9. Okay, just a few more. Number 4. Okay, 5y minus 1 over 1 minus 5y equals 1/4. Okay, this time, least common denominator. What would get rid of the 1 minus 5y and the 4? Via? Good. 4 times the quantity, 1 minus 5y. Okay, now this time, I'm looking for my restrictions before I move on. This time, it maybe isn't quite so obvious what y could or could not be if that denominator is going to be 0. So you could do some guess and check, but one easy way, if something doesn't just jump right out at you, if it's not completely obvious, keep in mind that I want to know when this is going to be 0. So if I set that equal to 0, if I say 1 minus 5y equals 0, and I solve for y, that will tell me the value of y when my denominator is 0, which is what I'm looking for. Does that make sense? Okay, so if I go through and solve this, subtract 1 from both sides, so minus 5y equals negative 1, divide both sides by negative 5. So this tells me that... So that tells me that if y equals 1/5 when I set my denominator equal to 0, this means when y equals 1/5, this equals 0. So this is my restriction. Y cannot be 1/5. Okay, makes sense? So if it's not completely obvious what the value of your variable would be for a denominator to be 0, go ahead and set it equal to 0 and solve. Okay, I want you guys to try to finish this one on your own and see what you get. Okay, hopefully, whenever you multiply by the least common denominator and you cancel out your denominators, we should end up with y equals 1/5. We all get that? Okay, what's the problem with that answer? Right, I said at the very beginning that y can't be 1/5 because when y is 1/5, my denominator is 0. So what does this mean? No solution. Very good. Did all that work for nothing? Just kidding, not for nothing. For fun, right? That's fun. Okay. Okay, we'll do one more together, and I'll let you do the last one all on your own. Okay, number 5. Okay, 2 over n minus 3 equals 1 over 2n minus 6. Okay, first, my least common denominator. This one is a little different than the ones in the past. Least common denominator, keeping in mind that I'm looking for what I would multiply by to cancel out both of my denominators. Any suggestions? Tara?
2n minus 6.
Okay, 2n minus 6. I think that's a great starting spot. Okay, 2n minus 6 is going to get rid of the denominator on the right-hand side, right? But I'll still have that n minus 3. What do you think? Very good. Times n minus 3. Right? If I multiply by 2n minus 6 times n minus 3, both my denominators would cancel out. Okay? Now I need to state any restriction. So this time I have two denominators that I have to be careful with. So I'm going to check if n minus 3 equals 0, what would make that denominator 0? If n is what? 3. So I know n can't be 3. For 2n minus 6, maybe I'm not quite sure, so if I set it equal to 0, if 2n minus 6 equals 0, then that means n would have to be 3. So I really have the same restriction, okay? So I just know that whatever I solve for, n cannot be 3, okay? All right, so if I go through and multiply by my least common denominator, 2n minus 6 times n minus 3 times the quantity, 2 over n minus 3. And then on the right-hand side, doing the same thing, if I have enough room. Okay, and then cancel out your denominators. On the left-hand side, I should be left with 2 times the quantity 2n minus 6. On the right-hand side, I can cancel out the 2n minus 6. And I'm left with n minus 3 times 1, which is just n minus 3. And if I distribute the 2, I have 4n minus 12 equals n minus 3. Get my n's on the same side of the equal sign. I have 3n minus 12 equals negative 3. Add 12 to both sides. So I get 3n equals 9. And then finally, divide both sides by 3. So n equals 3. But I can't have that, right? Because we said at the very beginning, n can't be 3. So my answer once again would be no solution. Okay, questions so far? Yes?
What would happen if in an equation like 2n minus 6 minus 3? And what if there was different answers for n cannot be equal to 3? So if it was n cannot be equal to 3, n cannot be equal to 4.
So you'd have two restrictions, so there'd be two answers that you'd be looking at for. Good question. So did everybody hear that, what he asked? If there were two restrictions, so that could happen. Just two numbers to look out for. Okay, last one I want you guys to try on your own. Okay, try, there we go. 1 over 8 equals 3x minus 1 over 3x plus 1.